of the 5 most commonly missed problems from last week's CAS learning assignment. And one of the more commonly missed ones was number 1. In an operating electrical circuit, the source of potential difference could be. Now, a lot of people chose number 1, which is not correct. Now, what a voltmeter does is it measures the potential difference, but the potential difference is provided by a battery. So the voltmeter measures potential difference, the battery provides potential difference. So the battery would be the source of potential difference. Next one, we have a diagram below, represents a 3 ohm resistor connected to a 12 volt battery. Meters X and Y are correctly connected in the circuit. Now, right away, once you get familiar with the vocab, you know it's potential difference, and potential difference is measured across something. And if we have a point here and a point here, this is a potential difference across resistor of 3 ohms. So right away I know that Y has to be a voltmeter, and when we think of an ammeter or something that measures current, we want all of the current to go through the ammeter, and at point X there's only one path for it to take, where we know that Y cannot be an ammeter because some current will split and go up, and others will other amount of charge will go right through resistor of 3 ohms. Now, as far as the number, so let's just talk about that. We know that Y has to be voltmeter, so right away we can eliminate choices 1 and 2, which show that Y is measuring current when we know that's in fact not the case. So X is definitely measuring current. Now let's look at the numbers. A 3 ohm resistor, a 12 volt battery. So right away, if I do Ohm's law, R equals V over I, there's a total resistance of 3 ohms in this circuit. I'm given that the voltage is 12 volts, and I'm looking for the current. Cross multiply, and 12 divided by 3 is 4. I get a current of 4 amps, making choice 4 the correct answer to number 3. And since there's only one resistor, all of this voltage will drop across resistor 3, and we know that it has to be 12 volts. Okay, which current diagram represents the correct way to measure the current in a resistor? Well, right away we can eliminate 2 and 4 because voltmeters do not measure current, so we don't want to look at those. And now again, to measure the current, we want to make sure all of the current goes through that resistor, where when we get to look at choice 3, some of the current will split that way and some will go. So all of the current will not be measured in this ammeter, making choice 1 the correct answer. Okay, now which circuit has the smallest equivalent resistance? Now, 2 and 4 are the easier ones to calculate. They're very quick because these are in series. And based on my rules, on my reference table, we just add them all up for a series circuit. So for 2 has the total resistance of 4 ohms, and 4 has 2, 2, 2, 2. Add those up, it has a total resistance of 8 ohms. Now we're on to look at choices 1 and 3. So for 1, we have 1 over R1. And again, these rules are right in your reference table. Oops. And I'm just going to plug that in my calculator. and choice 1 has a resistance of 1 ohm. So I can eliminate 2 and 4 because so far 1 is the smallest resistance. And now I'm going to do the same thing for choice 3, except now there's 1, 2, 3, 4 resistors. Apologize for this handwriting right now. And I'm again going to plug that in my calculator. So the 2 to the negative 1 plus 2 to the negative 1 plus 2 to the negative 1 plus 2 to the negative 1, enter, and then answer to the negative 1. And for choice 3, we're going to get an equivalent resistance of 0.5 ohms, making choice 3 correct. If we keep adding resistors, the resistance will keep going down. So the more resistance or the more resistors in a parallel circuit, the smaller the equivalent resistance. And then last one, a 3 ohm resistor and a 6 ohm resistor are connected in series in operating electrical circuit. If the circuit through the 3 ohm resistor is 4 amperes, what is the potential difference across the 6 ohm resistor? Okay, first thing I want to note is that it's a series circuit. Now, in a series circuit, current is the same everywhere. So if it's 4 amps through one resistor, through the other resistor, the current is going to be 4 amps. And that's going to be a very important relationship to help me solve my problem. And now I want to find the potential difference across a 6 ohm resistor. It doesn't really matter what else is going on in the circuit. Potential difference is voltage. So I'm going to use Ohm's law to figure out what we got going on here. We're given that it's a 6 ohm resistor. We're looking for potential difference, and I know that the current is 4 amps. So multiply that out, and we should have 24 volts as our final answer.